It is often, other than being a tongue twist. Labeled data is actually a luxury. It's not so easy to find a perfectly labeled dataset. And if that's the case, we can try unsupervised learning. Let's say I want to create a pizza classifier. Should I manually take photos of millions of pizzas on the plate and label each of them? This will probably take a lifetime. However, you can try to use unsupervised learning. Unsupervised learning, as I mentioned before, means that machine is left with a pile of data and a task to find out what's what. There is no teacher, there is no supervisor, data is not labeled, the machine figures out patterns on its own. There are three main methods within unsupervised learning: clustering, dimension reduction, and association rule learning. And let me dive deeper into them. Clustering is basically when the machine divides objects based on unknown features. The machine chooses the best way and decides what matters when it comes to cluster these different types of classes that we might have in the dataset. Clustering is often being used for market segmentation, for example, the types of customers, their loyalty, for image compression, to analyze and label new data, and to detect abnormal behavior. Popular algorithms: K means clustering, min shift, DB scan, or however it is pronounced. Don't kill me if I did it wrongly. You can read all about it in the description box. I left it there for you, so check it out. Clustering is a classification with no predefined classes. It's basically like dividing the socks by color when you don't remember all the colors of the socks that you may have, which happens to me as well. Clustering algorithms are basically trying to find similar objects by some kind of features we are not exactly sure about and merge them into a cluster. Now, those who have lots of similar features are joined in one class. With some of the algorithms, you can even specify the exact number of clusters you want. A great example of clustering is markers on web maps. When you're looking for, let's say, ramen restaurants near you, the clustering engine groups them to blobs with a number. Otherwise, your browser would probably freeze trying to draw all 3 million ramen restaurants around town. Apple Photos and Google Photos services use more complex clustering. They're looking for faces in the photos to create albums of your friends. The apps don't know how many friends you have and how they look, but is trying to find common facial features. Just like classification, clustering can also be used to detect anomalies. If user does not behave normally after signing up, let the machine ban him or her temporarily and create a ticket for support to check it. Maybe it's a bot. We don't even need to know what the abnormal behavior is. We just upload all the user actions into a model and let the machine decide what's normal and not. Another method of unsupervised learning is dimension reduction, also known as generalization. Dimensionality reduction basically assembles specific features into a more higher level. It is being used in recommendation systems, topic modeling and other document search, fake image analysis, risk management, and more. Popular algorithms here have complicated names, so I will use the shortcuts: PCA, SVD, LDA, LSA, TSNE. And again, you can find more info in the description box below. It's always more convenient for people to use abstractions rather than a bunch of fragmented features. For example, we can merge all dogs with triangle ears, small size, short hair fur, long tail, into a nice abstraction chihuahua. This new abstraction will be more useful for naming and explaining purposes. The recommendation systems is a super popular example of dimensionality reduction method. If you care to use it to abstract user ratings, for example, you can end up with a great recommendation system for music, books, movies, and games, and anything you want, basically. It's barely possible to understand this machine learning abstraction, but it's possible to see some correlations on a closer look. For example, some of them might correlate with users' age. Kids play Roblox and watch cartoons more than any other age group. Others correlate with movie genres or user hobbies, for example. Machines get these higher level concepts even without understanding them, just based on the user ratings. And finally, association rule learning. Association rule learning, other than being a tongue twister, also looks for patterns in the stream of orders. It is often being used to forecast sales and discounts, analyze goods bought together, place the products on the right type of shelves, and analyze web surfing patterns, for example. Popular algorithms here: a priori, Euclid, FP growth. There you go. Association rule learning includes all of the methods to analyze shopping carts, automate the marketing strategy, and other event-relevant tasks. When you have a sequence of something and you want to find patterns in it, this is for you. For example, a customer takes a bottle of wine and goes to the checkout. Should we place chips on the way? How often do people buy them together? It might be a good idea, it might not, depending on the pattern. What other sequences can we predict? Can a small change in the way we arrange the product lead to the increase of the profit? It's good for both retail stores, and the same goes for e-commerce.